Albert Einstein was one of the greatest and the most celebrated physicists of all time, and his discoveries changed the way we view the world on a scientific level. His life's work has expanded our understanding of science and opened up possibilities for many other breakthroughs. Some of Einstein's contributions. Theory of Relativity. The theory of relativity is one of the most important and influential ideas in physics. Developed in 1905, it changed the way we think about space and time, energy and matter, and the universe itself. It explains the behavior of objects in the universe and offers a framework for understanding many of its processes. At its core, the theory of relativity states that space and time are not absolute, but rather they are relative to the observer's frame of reference. The theory of relativity also states that mass and energy are equivalent, meaning that energy can be converted into mass, and vice versa. The theory of relativity has greatly impacted our understanding of the universe. It is used to explain phenomena such as gravitational waves, black holes, neutron stars, quasars, and more. It also provides the basis for modern cosmology and other branches of physics, such as quantum mechanics. Photoelectric effect. The photoelectric effect is an important phenomenon in physics. It was first observed in the early 1900s when Einstein proposed a revolutionary explanation for it. In essence, light energy is absorbed and converted into electrical energy when light photons are incident on a metal surface. This has many implications in the world of electronics as it is the basis for photodetectors, which are used to measure light, detect motion and other such applications. Photoelectric effect has a number of real-world applications. One of the most well-known is the photodiode, which is a device that detects light and converts it into electricity. These are used in devices such as cameras and photocopiers. Additionally, solar cells rely on the photoelectric effect to convert sunlight into direct current (DC) electricity. This is used to power everything from homes to electric cars. Mass energy equivalence E equals MC2. The mass energy equivalence E equals MC2 is a fundamental equation of Albert Einstein's special relativity. It states that matter and energy are related, and can be converted from one to another. This equation has been used to explain many phenomena in the cosmos, including how stars create energy through nuclear fusion and how black holes convert matter into energy. At its most basic, E equals MC2 explains that energy is equal to the product of mass and the speed of light squared. In other words, mass can be converted into energy and energy can be converted into mass. One of the most fascinating applications of E equals MC2 is its use in explaining astrophysical phenomena like the formation of stars and supernovae. In these events, enormous amounts of energy are released when two stars collide, which is explained by this equation. In addition, the formation of black holes is also attributed to the mass-energy equivalence. As matter is pulled into a black hole, it is converted into intense gravitational energy. General theory of relativity. General relativity is a theory of gravitation developed by Albert Einstein between 1907 and 1915. The theory of general relativity says that the observed gravitational effect between masses results from their warping of spacetime. The general theory of relativity also describes how gravity affects light. It states that as light passes through a gravitational field it is bent, creating a distortion in space-time. Einstein spent over a decade researching the theory of relativity before publishing his findings in 1915. He relied on mathematical equations to develop the theory and tested it with observations. One of his most famous observations was the concept of gravitational lensing. He used this observation to explain the bending of light around massive objects like stars and planets. Since its publication, the general theory of relativity has been further studied and developed by other scientists. Brownian motion. Einstein's theory of Brownian motion provides us with direct visual evidence for the existence of the point-like structure of matter. It suggests that we can see with our own eyes the molecular thermal motion. Bose-Einstein condensate. In condensed matter physics, a Bose-Einstein condensate (BEC) is a state of matter that is typically formed when a gas of bosons at very low densities is cooled to temperatures very close to absolute zero. Bose-Einstein condensate was first predicted, generally, in 1924-1925 by Albert Einstein, crediting a pioneering paper by Satyendra Nath Bose on the new field now known as quantum statistics. BECs have also been used to create atom lasers, atomic clocks and gravitational, rotational or magnetic sensors with excellent sensitivity. In terms of the experimental techniques, making atomic BECs in the lab has become routine.